Hello, in this lecture we will find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. Here all the 6 interior angles are equal to each other, and all the 6 sides of this regular hexagon are also equal to each other. We also know that line segment PB equals to 3 units in its length, and our mission here one side of this regular hexagon AB equals to 2 units according to what is given us in the question, and therefore all the other sides must be also equal to 2 units because of the fact that all the sides of any regular hexagon are equal to each other. This equals to 2 units, and this also equals to 2 units. And our mission is to find out the length of line segment AP or PA that is equal to X according to what is given us in the question. Okay, so first of all we will find out what is the sum of the angles in any regular hexagon. So I will draw a regular hexagon and find out the sum of the interior angles in that regular hexagon. So here A, B, C, D, E, F is a regular hexagon. That could be any regular hexagon. And in order to find out the sum of the 6, we have 2, 4, 6 interior angles. In order to find out the sum of the 6 interior angles of this regular hexagon, we join points B and E together by a straight line. By joining points B and E, we created here 2 quadrilaterals. Quadrilateral ABFE, this quadrilateral, and quadrilateral BCDE. And we also know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in this quadrilateral ABEF it is equal to 360 degrees. And the sum of the angles in quadrilateral BCDE it is also equals to 360 degrees. And the sum of the angles in those 2 quadrilaterals will be equal to the sum of the angles in this regular hexagon. Why? Because of the fact that this regular hexagon consists exactly those 2 quadrilaterals. So 360 degrees plus 360 degrees, that is equal to 720 degrees. It is the sum of the angles in this regular hexagon, and because of the fact that this regular hexagon A, B, C, D, E, F could be any regular hexagon, it means that the sum of the angles in any regular hexagon it is equal to 720 degrees. And I also mentioned that all the 6 internal angles in any regular hexagon are equal to each other. Here we have 2, 4, 6 internal angles that are equal to each other. So actually, therefore, the size of one internal angle will be equal to the sum of all the 6 internal angles, that is 720 degrees, over the number of the internal angles, that is 6. Why? Because all the internal angles are equal to each other. And therefore, the size of one internal angle will be equal to the sum of the total internal angles, that is 720 degrees, over the number of the internal angles, that is 6. So 720 degrees over 6, it is equal to 120 degrees. So we actually found out that each angle in any regular hexagon it is equal to 120 degrees. Here, this angle equals to 120 degrees in its size. This angle equals to 120 degrees. 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 And finally, this angle, it is also equal, this internal angle equals to 120 degrees in its size. Okay, so in the next step, we will extend side DC by a straight line. By extending side DC, we'll define this point as point L. So DC is one side out of the 6 sides of this regular hexagon, and as a side of a regular hexagon, it is absolutely a straight line. And we extended the straight line DC by a straight line. We got line segment DL, and when you extend the straight line by a straight line, the result must be a straight line. Therefore, line segment DL is a straight line. I write it down. So actually, line segment DL is a straight line. And we also have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this left side of the straight line DL and point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at the left side of the L point C? We have this angle that is equal to 120 degrees plus the missing angle, that is angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. So I write it down. 120 degrees plus the missing angle, that is actually angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Here we subtract 120 degrees from this equation, and we get that the missing angle, angle BCL, equals to 180 degrees minus 120 degrees, it is 60 degrees. Okay, so we can write down here that the missing angle BCL equals to 60 degrees in size. In the next step, from point B, we will draw perpendicular on DL. Again, from point B, we will draw perpendicular on DL. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created the right triangle BCM. Okay, so I'll copy the right triangle in a new page and we'll analyze this right triangle. Okay. So actually, this is the right triangle BCM that I copied from the original drawing. Angle MBC equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees. That is angle BMC equals to 90 degrees according to our construction. The hypotenuse BC equals to 2 units because of the fact that it is one side out of the 6 sides on this regular hexagon, and we know that all the 6 sides of this regular hexagon are equal to each other, and each side equals to 2 units. So in this triangle, the right triangle BCM, cosine 60 degrees here it is CM right triangle MB. This is actually MB. Okay, actually this is the right triangle BCM that I come from the original drawing. In this drawing, it is very easy to see that cosine 60 degrees equals to CM over CB. Okay. Cosine 60 degrees equals to CM over CB. Okay. Cosine 60 degrees equals to 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM. CM is the missing side, so we leave it as it is, over the hypotenuse CB. CB equals to 2 units, so we substitute CB by 2. In conclusion, we found out that 1/2 equals to CM over 2. Here we will multiply this equation by 2, and we get that Cm equals to 1 unit. Okay, Cm equals to 1 unit. So we can write down here that Cm equals to 1 unit, and also in the original drawing that Cm equals to 1 unit. We'll continue to focus on the same right triangle, triangle BCM. This right triangle, sinus 60 degrees equals to BM over BC. Again, sinus 60 degrees equals to BM over CB. So write it down, sinus 60 degrees equals to BM over CB. Sinus 60 degrees equals to the square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to BM. BM is the missing side, so we leave it as it is, over CB. CB, the hypotenuse CB equals to 2, so we substitute CB by 2. In conclusion, we found out that B square root of 3 over 2 equals to BM over 2. Here we multiply this equation by 2, and we get that BM equals to the square root of 3 units. Here, side BM equals to the square root of 3 units. You can write down in the original drawing that BM equals to the square root of 3 units. In the next step, we'll focus on the right triangle, triangle PMB. Side PM equals to PC plus CM. PC, line segment PC is unknown, so we will find the length of line segment PC as A, and we know that CM equals to 1. In total, side PM equals to PC plus CM. PC is A, CM is 1, so therefore PM equals to A plus 1. Side BM equals to the square root of 3 units. And finally, the hypotenuse PB equals to 3 units according to what is given as the question. So I'll copy the right triangle PMB in the new page, and we will implement here the Pythagoras theorem. So actually, this is the right triangle, triangle PMB that I copied from the original drawing. Side PM equals to A plus 1. Side BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units according to what is given us the question. We will implement in this right triangle PMB the Pythagoras theorem. So here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is PB. Therefore, the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. Repeat again, according to the Pythagoras theorem, in this right triangle PMB, PB square equals to PM square plus MB square. So PB equals to 3 units. Therefore PB square is 3 square, that is 9, and it is equal to PM square. PM equals to A plus 1, therefore PM square equals to A plus 1 square. Plus BM square. BM equals to the square root of 3, therefore BM square equals to the square root of 3 square. In conclusion, we found out that according to the Pythagoras theorem, 9 equals to A plus 1 square plus square root of 3 square. Square root of 3 square is 3. So 9 equals to A plus 1 plus 3. Here we subtract 3 from this equation and we'll get that 9 minus 3 is 6. 6 equals to A plus 1 square. So here we'll take a root out of this equation and we'll get that square root of 6 equals to A plus 1. Here we subtract 1 from this equation and finally we'll get that A equals to the square root of 6 minus 1 units. Okay, so you can write down in the original drawing that PC that is equal to 8 is equals to the square root of 6 minus 1 units. Okay, so in the next step we will join points A and C together by a straight line. By joining points A and C, we created the triangle ABC. This is triangle ABC. We know that angle ABC, this angle ABC, it is 1 out of the 6 interior angles of this regular hexagon, and we know that all the interior angles are equal to each other. Each of them is equal to 120 degrees in its length, therefore angle ABC equals to 120 degrees. Okay, so we will implement on this triangle ABC. We know that side AB equals to 2 units and side BC equals to 2 units also, because of the fact that those two sides of the triangle are also the sides of the regular hexagon, and we know that all the sides of this regular hexagon are equal to each other, and if each side is equal to 2 units. So we will implement the law of cosines in this triangle ABC, in order to find out the value of AC. Okay, so first of all I will remind to you what is the law of cosines. Actually, the law of cosines is true in any triangle. So we have here triangle ABC. That could be any triangle, not necessarily our triangle ABC, but any other triangle. This is triangle ABC. We know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And we also know that the angle between side AB and side AC is theta. Then, according to the law of cosines, that it is true in any triangle, we get that c squared equals to a squared plus b squared minus 2 times a times b times cosine theta. Again, theta is the angle between side AB and side AC. So in any triangle, this equation is told that c squared equals to a squared plus b squared minus 2 times a times b times cosine theta. So we implement the law of cosines in triangle ABC, so I'll copy triangle ABC in a new page and we implement the law of cosines in that triangle. So triangle ABC again, angle ABC equals to 120 degrees. Side AB equals to 2 units and side CB also equals to 2 units. So actually, this is triangle ABC that I copied from the original drawing. So we'll implement the law of cosines in the triangle ABC in order to find out the length of side AC. According to the law of cosines, we'll get that AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. So actually this equation is the implementation of the law of cosines in this triangle ABC. Okay, so AC squared equals to AB squared. AB equals to 2, therefore AB squared is 2 squared, it is 4, plus CB squared. CB equals also to 2, therefore CB squared is 2 squared, it is 4. And here we have minus 2 times AB is 2, CB is 2, and cosine 120 degrees equals to minus 1/2. So actually, in this expression, we have minus times minus, that is plus, so this expression in total will be a positive expression, and 2 times 2 is 4, and 2 over 2 is 1, so those two will get cancelled, and we left only with 4, so it is plus 4, and therefore AC squared equals to 4 plus 4 plus 4, this is 12. AC squared equals to 12. Here we substitute 12 by 4 times 3 and we get that AC squared equals to 4 times 3. Here we'll take a root out of this equation and we get that AC equals to the square root of 4 times 3. We can take 4 out of the root and the square root of 4 is 2, so in total we get that AC equals to 2. Inside the root we have only 3. So we found out that AC equals to 2 times square root of 3. We can write down here that AC equals to 2 times square root of 3 units We continue to focus on this triangle ABC, and we will find out the sizes of those two angles. We know that side AB equals to side BC, both sides are equal to 2 degrees, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, those equal sides must be equal to each other. So if one angle equals to x, then the other angle must be also equal to x. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in triangle ABC? We have this angle that is equal to x, plus this angle that is also equal to x, plus this angle that is equal to 120 degrees. In total, the sum of those three angles must be equal to 180 degrees. According to the rule, the sum of the angles in any triangle is equal to 180 degrees. So x plus x is 2x. 2x plus 120 degrees is equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We will divide this equation by 2, and we get that x equals to 60 degrees over 2 is 30 degrees. So this angle equals to x equals to 30 degrees, and this angle that is also equals to x equals to 30 degrees. So actually this is angle ACB, and we found out that angle ACB equals to 30 degrees in its size. So you can write down in the original drawing that this angle ACB equals to 30 degrees. Okay, and we know that angle PCB, it is one out of the 6 angles of the one out of the 6 interior angles of this regular hexagon, and therefore it is equal to 120 degrees. So the big angle PCA equals to 120 degrees, the small angle ACB equals to 30 degrees, and therefore the missing angle, that is angle PCA, will be equal to the big angle minus the small angle. So we'll draw again the three angles, and it will be clear more by drawing the three angles. On a new page, we have the big angle PCB that is equal to 120 degrees. So this is the big angle PCB that is equal to 120 degrees in its size. We have the small angle ACB that is equal to 30 degrees. So angle ACB equals to 30 degrees. The small angle ACB equals to 30 degrees. So the missing angle, so this is angle PCA, this is angle ACB is equal to 30 degrees, the small angle. Therefore, the missing angle PCA will be equal to the big angle PCB minus the small angle ACB. So write it down. The missing angle PCA will be equal to the big angle PCB minus the small angle ACB. Therefore, the missing angle PCA will be equal to the big angle PCB, that is equal to 120 degrees, minus the small angle ACB, that is 30 degrees. So we found out that the missing angle PCA equals to 120 degrees minus 30 degrees, it is 90 degrees. So the missing angle PCA is a right angle, it is equal to 90 degrees. So actually, this is a right angle. And because of the fact that angle PCA is a right angle, it means that triangle PCA is a right triangle. Okay. So here, angle PCA equals to 90 degrees. It is a right angle, and therefore triangle PCA is a right triangle. So the green triangle PCA is a right triangle because it has one angle that is equal to 90 degrees. So I will copy the right green triangle PCA in a new page, and we will implement the Pythagoras theorem on this right green triangle PCA. Okay, so here we have right triangle PCA. Side AP equals to x, according to what is given as the question. Side AC equals to 2 times square root of 3 units, according to what we have already found out. And finally, side PC equals to the square root of 6 minus 1 units. This is the value of A. So actually, this is the right triangle PCA. This is a copy from the original drawing. We will implement the Pythagoras theorem on this right triangle PCA. So here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle APC is AP. Therefore, the square of the hypotenuse is AP square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC square plus AC square. So in conclusion, found out that according to the Pythagoras theorem, in the right triangle APC, AP square equals to AC square plus PC square. AP equals to x, therefore AP square is x square, and it is equal to PC square. PC equals to the square root of 6 minus 1 units, therefore PC square is square root of 6 minus 1 square, plus AC square. AC equals to 2 times square root of 3, therefore AC square equals to 2 times square root of 3 square. Okay, so x square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. 2 times square root of 3 square is 2 square, that is 4, times square root of 3 square, that is 3. 4 times 3 is 12. In total, this expression equals to 12. So we found out that x squared equals to the square root of 6 minus 1 squared plus 12. In order to find out the value of this expression, square root of 6 minus 1 square, we'll use the algebraic identity that states that a minus b squared equals to a squared plus b squared minus 2 times a times b. In our expression, in our specific expression, a equals to the square root of 6 units, b equals to 1, and therefore, according to this algebraic identity, a minus b squared equals to a squared plus b squared minus 2ab. The square root of 6 minus 1 squared will be equal to a squared. So a is square root of 6, therefore a squared is square root of 6 squared, that is 6, plus b squared. b is 1, so b squared is 1 squared, that is 1, minus 2 times a is square root of 6 times b, that is 1. So in conclusion, we found out that square root of 6 minus 1 square according to this algebraic identity equals to 6 plus 1, that is 7, minus 2 times square root of 6. Okay, so we can substitute this expression square root of 6 minus 1 square by 7 minus 2 times square root of 6. We'll do it now and we'll get that we have this equation that x squared equals to the square root of 6 minus 1 square, and the square root of 6 minus 1 square equals to 7 minus 2 times square root of 6 plus 12. Okay, and we have here x squared that is equal to 7 plus 12, that is 19, minus 2 times square root of 6. So here we take a root out of this equation and we get that x equals to the square root of 19 minus 2 times square root of 6 units. Or in terms of numbers, x equals to 3.755 units. And that is the answer to our question. I'll repeat again. 9/7 AP is equal to x equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, x equals to 3.755 units. Okay, so in the next step I will summarize the lecture. In the drawing, we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal interior angles. Okay, and we also know that 9 segment PB equals to 3 units, and side AB equals to 2 units. Therefore, all the other sides must be also equal to each other, because of the fact that in any regular hexagon, all the sides are equal to each other. Okay. So, in the first step, we actually found out what is the sum of the angles in any regular hexagon. So here I draw a regular hexagon A, B, C, D, E, F. That could be any regular hexagon, and we found out the sum of the angles in this regular hexagon. In order to find out the sum of the angles in this regular hexagon, we joined points B and E together by a straight line. By joining points B and E, we created quadrilateral ABFE and quadrilateral BEDC. You know that the sum of the angles in quadrilateral is equal to 360 degrees, therefore the sum of the angles in quadrilateral ABFE is 360 degrees, and the sum of the angles in quadrilateral BECD, it is also equal to 360 degrees. And because of the fact that this regular hexagon consists exactly those two quadrilaterals, it means that the sum of the angles in those two quadrilaterals will be equal to the sum of the angles in this regular hexagon. And the sum of the angles on those two quadrilaterals will be equal to 360 degrees plus 360 degrees, that is 720 degrees, and therefore the sum of the angles in any regular hexagon equals to 720 degrees. And because of the fact that in any regular hexagon we have 6 interior angles that are equal to each other, therefore the size of one interior angle will be equal to the sum of all the 6 angles, that is 720 degrees, over the number of the interior angles, that is 6. So 720 degrees, that is the sum of the total angles over the number of the angles, that is 6, will give us the size of one angle, of one interior angle. So 720 degrees over 6 is 120 degrees. So found out that each interior angle in any regular hexagon it is equal to 120 degrees. Therefore all the exterior angles here, all the interior angles are equal to 120 degrees in this regular hexagon A, B, C, D, E, F. In the next step, we extended side DC by straight line, and this way we got the straight line DF. DL is a straight line, because when you extend a straight line by straight line, the result must be a straight line. So DL is a straight line, and we know that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at the left side of DL at point C? We have this angle is equal to 180 degrees. Plus the missing angle BCL, in total they must be equal to 180 degrees according to rule number 1. I'll repeat again. 120 degrees plus the missing angle BCL must be equal to 180 degrees according to rule number 1. Here we subtracted 120 degrees from this equation. We found out that the missing angle BCL equals to 180 degrees minus 120 degrees, this is 60 degrees. So here this angle equals to 60 degrees. Then from point B we draw perpendicular on DL. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. In this way we created the right triangle, triangle BCM. This is the right triangle BCM that is covered from the original drawing. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. In this triangle BCM, cosine 60 degrees equals to CM over CB. Cosine 60 degrees is 1/2, and it's equal to CM, and CB is 2. So 1/2 equals to CM over 2. We multiply this equation by 2, and we found out that CM equals to 1. Here CM equals to 1, and here we can write down that CM equals to 1. Likewise, we continue to focus on this right triangle, triangle CMB. In this right triangle CMB, sine of 60 degrees equals to BM over CB. Sine of 60 degrees equals to BM over CB. We substitute sine of 60 degrees by square root of 3 over 2. And it is equal to BM, and CB equals to 2. So square root of 3 over 2 equals to BM over 2. We multiply this equation by 2 and found out that BM equals to the square root of 3 units. Here, BM equals to the square root of 3 units. Then we focus on the right triangle, triangle PMB. In this right triangle PMB, we define PCSA, and CM equals to 1, therefore PM equals to A plus 1. This is the right triangle PMB that are coming from the original drawing. PM equals to A plus 1, BM equals to the square root of 3 units, and PB equals to 3 units according to what is given us in the question. We implemented here the Pythagoras theorem, According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB squared. It must be equal to the sum of the sides of the perpendiculars. That is to say, it must be equal to PM square plus BM square. PB equals to 3, therefore PB square is 3 squared, that is 9. And it must be equal to PM square. PM is A plus 1, therefore PM square is A plus 1 square, plus BM square. BM is equal to 3, therefore BM square is equal to 3 square. So 9 equals to A plus 1 square, and the square root of 3 square is 3. Here we subtracted 3 from this equation, and found out that 9 minus 3 is 6. So 6 equals to A plus 1 square. Here we took a root out of this equation and found out that the square root of 6 equals to A plus 1. Here we subtracted the 1 from this equation and found out that A equals to the square root of 6 minus 1 units. Here A equals to the square root of 6 minus 1 units. In the next step, we join points A and C together by a straight line. By joining points A and C, we create a triangle ABC. This is triangle ABC. Angle ABC equals to 180 degrees because it is one out of the 6 interior angles of this regular hexagon, and we know that all the interior angles are equal to each other, and each of them is equal to 120 degrees. We implemented in this triangle ABC the law of cosines. What is the law of cosines? The law of cosines is true in any triangle. In any triangle, so here we have triangle ABC that will be any triangle. Side AB equals to units, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. So in this triangle, triangle ABC, that will be any triangle, C square equals to A square plus B square minus 2 times A times B times cosine theta. We implemented the law of cosines. Now triangle ABC. So I call it triangle ABC, this new page, and we implemented here the law of cosines. So according to the law of cosines, AC square equals to AB square plus CB square minus 2 times AB times BC times cosine 120 degrees. So AC square equals to AB square. AB is 2, so AB square is 2 squared, that is 4. Plus CB square, CB is 2, so CB square is 2 squared, that is 4. Minus 2 times AB is 2, and CB is also 2, and cosine 120 degrees is minus 1 half. So this expression, in this expression we have minus times minus, that is plus. So in total this expression will be a positive number, and therefore it will be equal to 2 times 2, that is 4, and 2 over 2 is 1. So in total this expression equals to 4. Therefore AC square equals to 4 plus 4 plus 4, that is 12. We substitute 12 by 4 times 3, so AC square equals to 4 times 3. We took a root out of this equation and found out that AC equals to the square root of 3 times 4. We took 4 out of the equation. The square root of 4 is 2, so in total we found out that AC equals to 2 times square root of 3. So we can write down that here that AC equals to 2 times square root of 3. Then we continue to focus on this triangle ABC, and we found out the sizes of those two angles. Because of the fact that side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we know that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is x, this angle must be also equal to x. And we know that the sum of the angles in any triangle is 180 degrees, therefore x plus 120 degrees equals to 180 degrees. X plus x is 2x, so 2x plus 120 degrees equals to 180 degrees. We subtracted 120 degrees from this equation and found out that 2x equals to 180 degrees minus 120 degrees is 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2 and found out that x equals to 60 degrees over 2 is 30 degrees. So this angle equals to 30 degrees and this angle equals to 30 degrees. So this angle is angle ACB, and the angle ACB equals to 30 degrees. So we can write down in the original drawing that this angle ACB equals to 30 degrees. We have the big angle PCB that is equal to 120 degrees, and therefore the missing angle, that is angle PCA, will be equal to the big angle PCB minus the small angle ACB. So I copied the three angles in the new page, Here, the big angle PCB equals to 120 degrees. The small angle is angle ACB, this is 30 degrees. Therefore, the missing angle PCA equals to the big angle minus the small angle. Again, the missing angle PCA equals to the big angle PCB minus the small angle ACB. So angle PCA, this is the missing angle, equals to the big angle PCB, this is 120 degrees, minus the small angle ACB, that is 30 degrees. So the missing angle here is PCA equals to 120 degrees minus 30 degrees, that is 90 degrees. So we found out that the missing angle PCA, it is a right angle. Therefore, triangle PCA must be also a right triangle. This is the right triangle PCA, the right green triangle. So I copied the right green triangle in a new page and implemented here the Pythagoras theorem. This is the right triangle PCA, then I copied from the original drawing. PC equals to the square root of 6 minus 1 units. PA, it is the hypotenuse that is equal to x, that is the line segment that we are looking for, and AC equals to 2 times square root of 3. Here we implemented the law of cosines according to the law of the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared. It must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PC squared plus AC squared. So AP squared equals to PC squared plus AC squared according to the Pythagoras theorem. AP is x, therefore AP squared is x squared. And it must be equal to PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. In conclusion, we found out that x squared equals to the square root of 6 minus 1 squared, and plus 2 times square root of 3 squared. 2 times square root of 3 squared, it is actually 2 squared times square root of 3. 2 squared is 4, and square root of 3 squared is 3. 4 times 3 is 12. So in conclusion, we found out that x squared equals to the square root of 6 minus 1 squared plus 12. Here, in order to find out the value of this expression, square root of 6 minus 1 squared, we use there the algebraic identity that states that a minus b squared equals to a squared plus b squared minus 2 times ab. So in our specific expression, a equals to the square root of 6 and b equals to 1. And therefore, this expression, according to this algebraic identity, will be equal to a squared. A is square root of 6, therefore a squared is square root of 6 squared, that is 6, plus b squared. B is 1, so b squared is 1 squared, that is 1. Minus 2 times a is square root of 6 times b, that is 1. So in conclusion, found out that square root of 6 minus 1 squared equals to 6 plus 1 minus 2 times square root of 6. 6 plus 1 is 7, so it is 7 minus 2 times square root of 6. So in conclusion, found out that square root of 6 minus 1 squared equals to 7 minus 2 times square root of 6. Therefore, we can substitute square root of 6 minus 1 squared in this equation by 7 minus 2 times square root of 6. We did it, and we found out that x squared equals to square root of 6 minus 1 squared, that is equal to 7 minus 2 times square root of 6 plus 12. And here 7 plus 12 is 19. So in conclusion, x squared equals to 19 minus 2 times square root of 6. Here we took a root out of this equation and we found out that x equals to the square root of 6 minus 2 times square root. X equals to the square root of 19 minus 2 times square root of 6 units. So in terms of numbers, x equals to 3.755 units. So here we found out that line segment AP that is equal to x, it is equal to either the square root of 19 minus 2 times square root of 6 units. So in terms of numbers, AP that is equal to x, it is equal to 3.755 units. Okay, thank you very much.